We developed Direct Drive to meet our customers' needs to solve known problems with spirals that are in the market today. Customers told us they really wanted to eliminate day-to-day, hour-to-hour production problems related with the spirals they had in their plant. What they really wanted was a spiral machine that they could know would come on Monday morning at the beginning of production cycle and not have to be touched through the entire production run or on the following weekend or on the production run. They just wanted a system that just ran with no adjustments required. Today, friction-driven or low-tension spirals are all operating under the Capstan friction principle. What this means is that the drum inside the center of the spiral is actually rotating faster than the belt, and the belt gets its power from the drum through frictional engagement. So spinning that drum faster or slower will impart a different amount of force to the belt. And changing this amount of speed difference is called overdrive, and by changing that we can have different tensions within the belt itself. First thing we set out to do was, is there a way to mechanically couple the belt to the drum? What we chose to do was to add a drive tooth to the inner edge of the belt and a drive tooth structure to the actual spiral drum. By doing that, the belt and the drum are now engaged just like a gear or a sprocket, so there is no reliance on friction coefficients to drive the belt. It's being physically driven by the tooth on the drum. One of the core principles behind direct drive technology is what we call the load reduction zone. As the belt enters the spiral and engages with the drive teeth on the drum, we actually shrink the drum diameter slightly. In this block you can see that this area is tapered, and this would be our load reduction zone. The direct drive system's load reduction area can be related to a simple rubber band. As the belt engages the drum, there is a certain amount of tension built into the system. One way to lower the tension in this rubber band is to simply move your fingers closer together, which is exactly what we do in a direct drive load reduction zone. We can vary the amount of load reduction in a spiral to really tweak the final tension of the belt. So as the belt comes in with whatever inherent tension it is from pulling itself through the return way, we reduce the diameter and we lower the tension in the actual spiral belt. So for the rest of its trip throughout the system, which can be minutes to hours, it's operating at extremely low tension. By running the belt at a very low tension, it prolongs the life of the belt for one, but also all the other components of the system. If the overall system is running in a more relaxed mode, all the bearings, the plastic, the wear strip material, everything else just lasts significantly longer. Direct drive is a very simple system overall. The two gear teeth, one on the drum, one on the belt, simply engage with each other to drive the belt. That's it. It's that simple.